Our last module for this semester is rocks and minerals, which is important, but can be a little bit dry, right? So I know rocks and minerals, you're like, okay, and it's not the most exciting thing ever, but what's great about it is it gives you a good foundation to talk about soil, right, which you can then apply to a bunch of different real life things. And also it gives you a really good foundation for kind of how these processes happen and thinking about natural resources and how we obtain them. So I'm going to really briefly go over rocks and minerals, the general properties of them, and then we're going to decide what the difference is between the two. We're going to talk about the collaboration project. I know it was due yesterday, and a lot of people looked at it yesterday for the first time and were confused. So we're going to talk about that a little bit, and then we're going to do the DBA. So the warm-up question today is just to get you thinking about this class again. What has been your favorite module so far this semester and why? So go ahead and think about that for a second. As a refresher, we had module 0 on measurement and like intro to science kind of stuff. We had module 1, which was, what was module 1? I don't even remember. Let's look really quick. Oops. Module 1 was something important. And then we had the water module for module 2. Module 3 was the light and space stuff. Oh yeah, module 1 was weather and climate, that's right. So climate and meteorology was module 1. Module 2 was water, groundwater, surface water, water conservation. Module 3, our universe, right? And then module 0 was that basic measurement, intro to science kind of stuff. So thinking about that, which module so far has been your favorite and why? Go ahead and pop an answer into the chat. Awesome, we got quite a few answers here. Shelby says, I liked the water module because I just like learning things about water in general, so it was really interesting. The assignments were fun. Devin says, I like the one on space and stars because they interest me a lot. Mark also agrees with space and stars. It's interesting to talk about wavelengths. And Vitali also agrees with the water, fresh water, because I learned how water can be conserved. Yelena liked the stars one too. Yeah, right? So the cool thing about this class is that we have so many different topics that hopefully one of them was interesting to you, right? Because we have everything from space all the way down to water, rocks, soil, and then even just how to measure things, which, you know, I'm not surprised nobody's jumping up and down about module 0 because, you know, you're like, measurement. But yeah, so there's the rocks and minerals one might become your favorite. You never know. Autumn says water because I liked learning more about water and different ways to conserve it. Desiree agrees on the water. Vanessa agrees on the universe. Yeah, right. So earth science is one of those kind of catch-all sciences where it sort of encompasses something from almost every discipline. So rocks and minerals. What is a mineral? I would recommend that you take notes. So I will give you a second before I begin talking. This PowerPoint also will be available, right? So, am I recording this? Yes, okay, good. I recorded the earth science session last time and for some reason it didn't work, which was really annoying. But this PowerPoint will be available for you to reference. So, what is a mineral? Minerals have one chemical composition. That means if we break it up into a million little pieces and we sample each piece, they are all the exact same chemical composition, made of the same elements. They are abiotic. That means they're non-living, right? Sometimes minerals can be produced from living organisms. Think about shells, right? On different sea creatures especially. I'm sorry. Like, my throat is super tickled right now. Trying to drink stuff to make it better, it's not working. Okay, hopefully that helped a little bit. And these are naturally occurring, right? And they're formed in Earth, I said, really on Earth, through various processes. So minerals are pretty, right? Usually we like minerals because they look cool. And I included this little chart of a bunch of different examples of minerals, right? Really common ones, quartz, right? There's different kinds of quartz, even granite. You guys might have heard of these words if you're like me and you like watching HGTV, right? Countertops are made of minerals, and they're expensive. People spend thousands of dollars on their countertops. We have a whole bunch of different minerals here. If you've ever been to any kind of science museum, you probably had a gift shop with, you know, a bucket of minerals that you could get, right, to take home, like little samples. But really, even diamonds, right, are considered to be minerals. So all of these really pretty stones are minerals. And some of them, of course, are natural resources that we really care about. And others maybe don't really have so much of a use, but they're still considered to be minerals. Oh, well, of course, diamonds are your favorite, right? Diamonds are beautiful. But hey, rose quartz is also beautiful. So minerals form from, right? How do they form? From crystallization, which can happen from a solution or from magma, right, from a volcano. And also they can form from heat and pressure. So think about a diamond, right, forming from heat and pressure. Crystallization really kind of means that like the water or the solution evaporates and leaves behind crystals. The same thing can happen with lava. So I found this little graphic over here that I thought you guys might find useful, right? For mineral formation, they can either come from molten material, aka lava, or from solutions, right? They are crystallized, and they can either happen underground in magma, from lava above ground from evaporation, or in veins underground. They can form crystals as a solution, either like seeps deeper or evaporates underground. So there's a bunch of ways that they can form. Not super important to memorize that, right? But just keep in mind heat and pressure and solutions really are the way that these minerals form. So as you can imagine, these are not quick processes, right? How long do you guys think it takes to make a diamond? Yeah, a long time. And then Shelby said a long time. Yeah, really long time, thousands of years. That's why diamonds are so expensive, right? Because they don't form very often and they need specific conditions and they take a long time. Other minerals maybe form with less time, but regardless, they need certain conditions and they need certain things to happen for them to form. Some of these things we can mimic in a lab and we can actually make minerals, right? But it's hard and expensive, right? And yes, Mark brings up a great point that diamonds are indestructible. So minerals, we'll see, they have different ways you can test them, but part of that is actually their hardness, right? And one of the ways that you do that is you try to scratch them. Diamonds can't be scratched easily. Other things, like for example, I have an opal ring. I don't know if some of you guys might have been able to see my ring, but an opal is a mineral, right? But it's much softer than a diamond. So an opal can be cut, right? It can be chipped and it can be broken. So you have to be super careful with it because if you hit it on something, it might break. Diamonds, you could bang around all day and they still look perfect. And you're right, Mark, you could cut a diamond with a diamond, right? It's almost like cannibalism, but in forms of diamond. So things that we can test for minerals, mineral properties, because really what we care about is their properties. Their hardness, which is what we're discussing right now. We use a special kind of hardness scale to determine that. And in the module, you guys are going to learn more about that. But we have a scale of 0 to 10, 10 being the hardest, which is diamond, right? And 0 being the softest. I believe talc, I think is what it's called, is one of the softest ones where you can kind of just barely touch it and it like breaks into a million pieces, right? And then there's things more in the middle like the opal and other types of stones that, you know, are hard but can be broken. Obviously the color of the mineral is going to be a property. The streak. So what that means is we take a white plate and you take your mineral and you can scrape it on the plate and it will leave behind a powder, a nice little fine thing of powder that will show you the streak of the mineral. And that may or may not be different than the color of the mineral, but it's a way that you can identify it. The luster, which is how it reflects light, right? So is it shiny or is it dull, right? Some minerals are really sparkly and pretty and others are not pretty. The density, right, which we're familiar, is mass divided by volume. Again, some minerals are super dense, others are not. The crystal shape, right? Some minerals form very specific crystal shapes, others are more clumpy, lumpy crystals. The cleavage, not the cleavage you're thinking of possibly, but meaning, does it split easily? So if you hit the mineral, does it have a clean break, right? Or does it just become a powder? The fracture, again, how the mineral looks when it breaks apart. And then other properties, right? Is it radioactive? Is it fluorescent, meaning it glows? Is it magnetic? Does it react to an acid? Can it be used for electrical properties, right? There's a billion other special properties that make certain minerals unique. On the other hand, rocks, they could be made of one mineral or many minerals. And technically, they're just a hard substance formed in several ways. Very vague, because we're going to go into how they're formed in a second. Right, but we're pretty familiar with rocks. I'm sure if someone said to you, hey, can you pick out the rock? You would say, yeah, it's this, right? Rock's pretty obvious, and can really, the main thing here is that it could be a combination of a bunch of different things. And again, sometimes rocks look really pretty, sometimes they don't. So I try to pick some cool looking rocks here. And, you know, you could Google rock and see 3 million kinds of rocks. So how do rocks form? Similar to minerals, except that they have this wonderful thing called the rock cycle, right? As if we didn't have enough cycles. We have carbon cycle, water cycle, right? Now we have rock cycle. It's not super complicated, but regardless, anything that you do on the rock cycle, you can always answer by looking at a graphic. So definitely print one of these out, draw one in your notebook, have one on hand because it's going to help you. So there's 3 kinds of rock. We have our igneous rock, our metamorphic rock, and our sedimentary rock. And then we also have these sort of secondary stages, magma, which is like liquid rock, and sediment, which is sort of like ground up rock, right? So there's only 3 kinds of rock technically, but within each kind, you're going to see many different examples of what that might look like. In fact, I should have included a picture of what these rocks look like. That would have been smart. So we'll do that right now. Igneous rock. So igneous rock looks like this, right? It's pretty nice, I think. It's pretty in some, maybe in some people's eyes, maybe not. But igneous rock, let's look at how it forms. Dragon fruit, yeah, it kind of does look like dragon fruit. That's a good description. So how does igneous rock form? It forms from magma that's crystallized. So Igneous rock is a direct result of lava, right? So it looks crystally, right? It looks like a crystal. It looks very minerally. It usually is composed of a ton of minerals inside of it. Okay, what about metamorphic rock? Can't really. I have too many things open. I can't see where I'm typing. Okay. No. Okay. Metamorphic, rock. Not quite as pretty, in my opinion. But this one looks more like what you see from cooling volcanoes. And if we look back at our rock cycle, how does it form? Right? It forms from heat and pressure. So if you take igneous rock and you apply heat and pressure, or you take sedimentary rock and you apply heat and pressure, you get metamorphic rock. So metamorphic rock, there's a bunch of examples here. It's usually like lines, right? Let's see. We got some examples here. Slate is probably one that you've maybe seen. Marble is probably the prettiest metamorphic rock, right? And then there's all these other kinds. So volcano is minerals. A volcano is composed of rocks and minerals, yes. Okay. And then our last type of rock, sedimentary rock, which is the type of rock that we're much more familiar with seeing in our everyday life. So sedimentary rocks are usually the kind of rocks you see outside, right? Sometimes they have holes in them, like porous from where gases were. Some of them are pretty colors. Some of them just look like regular rocks that you would find in your yard, etc. And how do those form, right? Sedimentary rock forms, from sediment, right? Which is basically a bunch of tiny pieces of rock getting compacted and cemented together. So you want to think about if you took like a bunch of tiny rocks and they were all kind of near each other, over time, more and more rocks would get compacted on top of them, and you end up getting like layers of rock that's been compacted. Right? So basically igneous rock and also metamorphic rock can get weathered and have erosion happen, right? From wind, water, humans, etc. That sediment gets compacted and cemented together to form sedimentary rock. If sedimentary rock melts, or if metamorphic rock melts, we get magma, which can crystallize and form igneous rock, right? So all these rocks are related. They can all become each other if there's the right conditions. If heat and pressure are applied to sedimentary rock or igneous rock, we get metamorphic rock. So essentially, all these rocks can sort of evolve into the next type of rock and go back. Again, this is a slow process and requires certain conditions. Crystallization is going to take certain conditions, right? Melting will take certain conditions. Heat and pressure will take certain conditions. Weathering and erosion takes forever. So all of these things take very special conditions and are slow, is really what I'm trying to say here. And let's look at more pictures of igneous rocks, because I kind of only showed us that one. And on the other ones, I showed many pictures. So this is a great way to use Google, by the way. So igneous rocks, right? Some of them also can be porous with holes in them. Obsidian is a really kind of famous one. It's super shiny. A lot of people really like that. But again, igneous rocks, many, many examples, right? Some of them are pretty. Some of them look like regular rocks, based on what you really think. But again, there's 5 million types of rocks. Of course, you're not expected to memorize all of them, but you might actually find some that you're like, ooh, this rock is cool. I want to know what it's called, right? So that is pretty much how the rock cycle works, that the 3 main types of rocks, well, the 3 only types of rocks, other than magma and sediment, they're interchangeable, right? Depending on what's happening in the earth and where they are, they could become other types of rock. So where do you think on Earth, where is heat and pressure going to be happening? In the Earth. Yeah, perfect way to explain it, Mark. So metamorphic rock is mostly being formed deep inside the Earth where there's a ton of heat and pressure. What about igneous rock? It's coming from crystallization of lava. Where is that happening? On the surface, right? Maybe in a volcano, kind of, but also on the surface, right? A beach island, sure, somewhere where a volcano erupted at one point. Sedimentary rock is from weathering, erosion, in deposition. Where would that be happening? Oh, I'm sorry that you're losing your connection. But where would we mostly see sedimentary rock? Near rivers, right? Yeah, that's the one that we're probably most familiar with because we're not really going deep in the earth or in a volcano on our average day. But yeah, sedimentary rock is the more common rock. You see it near rivers, right? Especially where rivers have carved through rock. The Grand Canyon, for example, is a good example of sedimentary rock. Also, sediment, right, we see as like little broken up pieces of rock. Magma we might see as lava. Okay, so just giving you some ideas there. So then you guys are going to tell me what's the difference between rocks and minerals. There's not just one, right? There could be many. So composition is a huge one. Great, Devin. So what is the difference in composition? Minerals are made of one thing, and rocks are made of many. Okay? What else? Good, thank you, Mark. Rocks can be made from one or more minerals, and minerals are one. Good. What else is different about rocks and minerals? They're cycles, right? Or how they're formed. They're formed in similar-ish ways, but the rock cycle is not how minerals are created necessarily. So the properties, Mark says hard, exactly. So hardness, right? Rocks are hard for the most part. Minerals can be hard or soft, right? Some of them break really easily. And other properties as well, right? Minerals can leave a streak, rocks not necessarily. They might, depending on what minerals are in them, but it would be a bunch of different colors. Yeah, so really those are the main two ones that you want to have here. Minerals are made of one thing, rocks are made of many. Rocks are hard, minerals can be hard or soft. And other properties too could be different between them. Okay, good. And then we'll go into our collaboration options and what we're supposed to be doing on this, because I know a lot of people have been like, what is going on with this collaboration? So the due date is not like a required due date necessarily. You need to turn in one of these projects by the end of the semester, right, which is January 25th. Now, you don't want to be waiting until January 25th to turn it in. I will not be putting zeros in for the collaboration project until the break, right? So during the December break, I will be putting zeros in for the collaboration project. That means you could still do it, but it's going to show you what will happen to your grade if you don't do it. There are 4 options from each of the modules. You're only required to do 1. Right? So you could pick the module that was most interesting to you. A lot of people liked water or the light and universe module, right? Possibly now that we kind of talked about rocks, maybe you're like, ooh, actually, I kind of want to do my project on rocks. Okay, pick the module that you enjoyed the most, which is why I asked you guys that question earlier, so you were thinking about that already, and then do the associated project. So where do you find the instructions, right? That's the next hard thing. So the actual turn-in spot in modules, there is a discussion board. That's what that little chat boxy thing means. So you could post in there if you're still looking for a partner, right? If you would prefer to do it by yourself, that's fine, but you will have to do everything by yourself. The part 1 and part 2 turn-ins are here in the collaboration module. Now, that doesn't give you the instructions, it just tells you turn it in. So you need to pick the module you want to do and look in modules, and you will see all the numbers that I listed here. Most of them are 0.05s. It tells you collaboration option. So we'll look at module 3 together as an example. So maybe I want to do module 3. Okay, I'm required to complete collaboration, blah, 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 blah. Okay. So space exploration, right? For this collaboration option, your team has been selected by the National Aeronautics and Space Administration, NASA, to research a variety of space exploration missions and help them make more important decisions based on your position. As a team, you will research and decide whether you believe we should continue to fund humans in space exploration and under what conditions. If you do not believe we should continue with humans in space exploration in the future, support your reasons with research and evidence. So, directions is going to be the tab that you want to click on. That's going to tell you specifically what is required. Again, if you're doing it by yourself, just replace each team member with you. So each team member should research a variety of manned and unmanned space exploration missions to share with the team. Research should include the costs and benefits associated with manned and unmanned missions, evidence that supports your opinion in support of manned or unmanned missions, and any conditions around your opinion. Use reliable resources such as, and they give you some website options here, right? You can use additional sources, but make sure they're good sources here. No Yahoo Answers, no Quizlet, those are not sources. Each team member will communicate your findings, right? And you need to do a presentation. Your presentation can be a Google PowerPoint, a Prezi, a script, a news article, a video, right? It looks like some of this has typos in it actually. And you know what's weird, guys? I can't actually edit this, so I can't fix that, but this one doesn't have a weather report. That's from module 1, so I don't know why it says weather report, but whatever. Or a news article, right? So you could record a video where you say, okay, I think that we shouldn't send humans to space anymore. Here's why. Here's all the missions that we sent humans to space. It cost $7 billion and we only learned 4 things, right? Versus we could just send probes and learn way more, whatever. Or you might think the opposite. You could just do a video of you talking about it, showing examples, mentioning examples, etc. Or you could do a PowerPoint, a news article, or a script as other options, right? If you're doing it by yourself, obviously you could just create that by yourself. If you're doing it with a partner, then plan it out. Hey, you're going to do this part of the video. I'm going to do this part of the video. You do this part of the PowerPoint. I'm going to do this part. Yeah, and that's pretty much the project. It shouldn't take you a terribly long amount of time to do. Right, all of these are pretty straightforward in terms of you're taking a position in this one. For the water, you're researching water conservation and actually how you can do that. And for module 1, you're doing a weather report. And for rocks and minerals, I actually haven't looked at what that one is yet, but that one will be about rocks and minerals and it'll be something similar. So you can do any type of presentation that you would like, right? But the main point of this is that you need to research. So it's not just your opinion, it's backed by research. And thank you, Mark, for helping Shelby out in the chat. You only have to do 1, right? So like I said, pick your favorite module that was the most interesting to you and just do that project. You're welcome to post in the chat here too, if you'd like. Say, hey, I'm looking for a partner. I want to do this module. See if anybody else is looking. And then you can also post in the chat in Canvas. You can do the project by yourself, right? You can do it with someone else. Whatever is easiest for you. I know right now there's a lot of, push to finish everything. So if you're really working hard and you don't have a lot of time to work with someone, I understand. All right, so hopefully that helps you a little bit on what you're supposed to do for the collaboration. Like I said, there's 4 options. They're all 0.05 except for module 1, it's 1.07. You can find that in modules, and you only have to do 1. So you just submit it into one of the Colab things since 2 pop up. Okay, so 2 pop up because part 1 is the project and part 2 is reflecting on how you did. So if you work by yourself, part 2, you're gonna say, I was awesome, I did a great job. If you worked with another person, part 2, like if I was Shelby's partner, I would say, Shelby did a great job. She was in charge of researching this mission, and I researched these missions. And here is a screenshot of our emailing back and forth where we decided who was doing what. And then that way I can see, oh, you collaborated, right? So part 2 is not a collaboration project, it's just reflecting on the project. Okay? So yeah, so you'll turn in your project for part 1, and part 2 you'll reflect on either yourself or if you worked with a partner, on your partner. Okay. Any other questions about Sydney? Yes. The code word is, I was writing it down so I don't forget. Oops, yep, there we go. That's the code word in the chat right now for everybody who's here. Make sure you get it. I'll repeat it at the end as well. And we'll talk about what the code word can get for you in a second. Okay, so collaboration, right? Make sure you're working on it. Get it turned in as soon as you can. Again, I'm not going to be putting zeros in until after December 15th, right? And even if you have a 0, you know, you can still go back and do it. So make sure you're getting that collaboration done because it is quite a few points, right? It can impact the grade heavily. Next thing is what you can use the code word for. You can get 5 bonus points on a quiz or an assignment. So any assignment or quiz in Canvas, it could be old, it could be new. If it's an old assignment, you probably want to email me and say, hey, I'd like to use my code word of blank for some points on this assignment or quiz. Can it be the final exam? It certainly can. So you can hold on to this and wait until the end of the semester, right? You can also, you know, I've given bonus points a few times and I probably will give one more. So you can combine them or keep them all together, right? So just make sure you have the code word written down. I would write somewhere too that it's worth 5 bonus points so that you don't forget why you wrote it down. And be strategic on what assignment you want to use it for. You could use it on your project, you could use it on your exam, right? You could use it on whatever. So make sure that you're doing that, and if you don't want to use it, that's fine. And then the last thing here is our Module 3 DBA. If you've already done the Module 3 DBA, feel free to leave the session right now because obviously you're not going to need to do it again. If you have not done your Module 3 DBA, remember this is the Light and the Universe module, then go ahead and come to this document here where we will do the DBA together. So just like before, go ahead and add your name to a box if you would like to do the Module 3 DBA. And I will get started here on the questions. Trying to remember what my other question was. Okay. Oh no. Okay. Okay. Just have this last question be. Can we answer them? Yeah, go ahead and start answering the question. So the first question is, what is light and what is a light year? Right, so describing light, describing what a light year is. Our second question is, how did the universe start and how do we know? And our third question is, what is the most interesting thing you learned about in Module 3? So remember, you can use your notes. You can Google for some inspiration, but again, make sure it's in your own words. Ooh, nice definitions. I like Desiree's light is both a wave and a particle. Very true. Mark says light is a visible electricity. Good. Light year is how much distance light can cover at the speed of 300 million kilometers per second. Okay. Light is a type of radiation, which is also visible to the human eye. That's a great description, Shelby. Don't forget to add in about light year. Okay. Okay, these answers look good, guys, so far. Ooh, I like that Vanessa's adding in that light years is a measurement that we use to track distances in space. That's great. Right, because light can travel so quickly, we can actually say something is so many light years away, and it obviously means really far, but it gives us a better idea. Okay, a lot of us saying universe started with the Big Bang, right? Good. Mark says his most interesting part of Module 3 was the types of electronic waves and particle waves, the different links on how they are used and used to determine types of stars and the colors. Yeah. So if you take chemistry, Mark, you'll actually learn about what each star, what elements are in it based on the colors that it produces, which is pretty interesting. I like seeing people correcting their typos and their spelling stuff. Very nice. Yeah, and Mark, feel free to leave when you're done with the DBA. That's actually going to be the end here of our session. So you have finished all 3 questions and they look good. So if you're satisfied with your answers, then you're free to leave the session. Okay, thanks, Mark. I'll be here for your other questions. And Vanessa, see if you can add to that what evidence that is. Right? Even just saying that the universe is still expanding, that counts as evidence for that, right? The fact that it's still growing. Oh yeah, how stars develop and form, right? And actually what's interesting too is that the life cycle of a star is pretty similar to the life cycle of a human, right? Okay, a lot of people interested in stars, how they're forming, how they get their names. Yeah, pretty interesting stuff. Few people still thinking about what their most interesting thing from Module 3 was. I know it's kind of a hard question because you got to go back and think about all the stuff that you learned. Ooh, radio science. Ooh, I like, Shelby, how you italicized much to emphasize your point there, right? You didn't think there was going to be that much of a difference. Yeah, it is surprising. I agree that they're just like the stars. You think, oh, they're all stars, but really they do have their own unique descriptions. How stars develop and form. Okay, we still got a couple people who are going to be adding to their last question here. What I'm going to do is I'm going to keep the document open here for another 15 minutes or so. So feel free to finish up your answers. I am going to respond to you if I see something that doesn't seem right or maybe that you need more explanation on. And Shelby is correct. There's not an exit slip. The exit slip is if you know the code word, you can get those 5 bonus points. I feel like right now a lot of people are working on catching up, so I didn't want to add extra assignments here. Okay, so if you did work on the DBA today, I will be putting those grades in probably this weekend, right? So look for those by Monday, and also be thinking about how you want to use those 5 bonus points. Otherwise, we're going to end the session. The document's still going to stay open, so feel free to keep typing those answers, keep thinking about it, making some edits if you need to. Otherwise, thank you guys for attending today, and I will see you next Friday. You have another DBA missing, Mark? Send me an email, Mark, and I'll send you the questions for it right now. Okay? We could do it by email right now. Just send me an email. Bye, everybody.